Hi everyone, good afternoon.
All right, guys, thank you so much. It was a very good session by Raghu and a couple of others who has given a session before us. So before we get into the topic for today, yeah. So the topic I'm going to talk about is about Karpenter. But before I start this, I would like to ask a couple of questions. So how many of you have started using Kubernetes? Oh, there are quite a few. Not a quite few, more number of people. So how many of you are using any of the open source scalers, autoscalers? Okay. How many of you started using EKS? Okay. Are there anyone using ECS? All right. I think then these are the right set of audience for this topic. Um, so the topic I'm going to cover, right, is about Karpenter, but what is the significance of it with respect to slashing costs and how it can boost the efficiency. So before I get into the topic, I just wanted to introduce about myself and Satyajit. I am Nagababu Medicharla and I'm a senior manager at Searce. Searce is an advanced consulting partner. I'll just talk about it. I'm an AWS community builder and NX ambassador. So I help many fintechs, startups, and other companies, right, to adopt cloud and modernize their applications with respect to microservices.
So I'm Satyajit. So I'm also working as a senior manager at Searce. So I'm a AWS ambassador and also a community builder. So I'm a multi-cloud and also managing all migrations, modernizations in Searce.
Yeah. So I and Satyajit come from a company called Searce. Searce is an advanced consulting partner, and we have a couple of competencies with respect to migrations, resiliency, DevOps, data analytics, and so many SDPs as well, service delivery programs. Yeah, so this is the agenda that we are going to look into today. So we will just talk 1-2 minutes about architecture, and then what is going to be the cluster to contain traffic flow, and how do we autoscale by using horizontal pod autoscaler, then node autoscaler, and we'll be talking about what is the significance of Karpenter. Yeah, so coming to EKS, so which is Elastic Kubernetes Service. Like any cloud provider, even AWS has their managed Kubernetes platform on AWS, and we're calling it as EKS. So if at all we look into the architecture of the EKS, so you are having two components. One is the management component and the other one is the data component, workload component. If you look to your left hand side, you are able to see that there is a EKS VPC. So that is where all of your management components sit, like API server and the etcd clusters and so on. The complete control plane sits there, and that is managed completely by AWS. So that is the reason we are saying that it is a managed service. We need not worry about whether the etcd cluster is updated or not, or anything else, like how is the control with respect to scheduling is happening. All the heavy lifting is done by the respective EKS VPC, and that is completely managed. So they are doing all the heavy lifting with respect to the management. And to the right hand side, when you are seeing this is the workload VPC, and this is the VPC that we as a people that was going to manage are responsible for this piece. So if at all you see, we are going to create our own VPC, get the respective subnets, and we will be deploying our EKS cluster here. So that means the respective node groups or the targets or anything, right? We'll just talk about it. All of these will be in here. So when we are going to get the respective pods deployed, there are multiple ways how you can get them deployed. So that's where you manage the compute. So you are having node groups where you define how many nodes you want to be there within the cluster, so that the respective pods can use them in order to schedule them. And also we have the different types again, right, where you can directly bring your respective AMI, and you can go and get that. You can just get the communication between the control plane and this, and but you have to manage all of those nodes by yourself, where you need to manage the respective patching and so on. There is a better way to do that, where we are calling it as managed node groups, where AWS manages all the respective nodes. Just define how many nodes you want and till how much it can go or it can scale up to. And apart from this, you're also having the EKS anywhere, so where you can just simply take it and deploy it by using the open source AWS distro, where you can get the EKS cluster flavor on your on-premise as well. So this is not it actually. We can also have the serverless containerization by using the Fargate. You can integrate Fargates with the EKS cluster as well. And it's not over. It's not only your AWS VPC and your cloud VPC. So since this is an open source platform coming in, right, there are multiple integrations that you can make. But all you see, all of the add-ons, we are calling it as add-ons, they are directly available with respect to EKS cluster, where you can go and just deploy that as an add-on. The primary add-ons that you get by default are core DNS with respect to EBS CNI and so on. And if at all you go continuously, right? So you're having multiple others with respect to Ingress. You're having the Nginx or the load balancer Ingress. Observability, you're having Prometheus, Grafana, Kubecast, and so on. And when it comes to auto scaling, you're having Kada, which is an open source, as well as Karpenter. So Karpenter is completely beating the other node autoscalers. So,
okay. So now we understand about the EKS cluster architecture high level. So if I go into deeper into that, so we have master node and worker node, and we know about all the components like your API server, etcd cluster, and all the things. So I'm not going to talk about that. Just high level. So when the components flow will be like, we have a EKS cluster. Inside the cluster we have a node group, and inside the node group we have respective nodes, and in the node we have pod, and at the end in the pod we have a container. So you can have a single container pod or you can have a multi-container pod. So this is high level. So you have a cluster, then node groups, then node, then pod and container. So now at the end our applications will be running on the container. Like we can use Docker image, or you can build the container. You can push into the ECR, and you can respective deployment, you can pick the container from the ECR. Now our application is running on container. So container is a private scope. It means it's running on a private pod. We cannot, at the end, our strategy is like how the applications can be accessible to outside world. So now as applications running on container, so it can be discoverable by the services. So we have Kubernetes services called like so we have services like many services. We have like node port, and we have cluster IP, load balancer, and ingress. So now applications running on pod, and we expose to via services load balancer, and customer is trying to access the applications, and it is working fine. Now what next? Like let's say application is working fine. Now there's a number of users increased, or number of load got increased. So that time our pod will not be sufficient to manage the load. So that time we need something, need to be scaling on pod level. So there HPA comes into picture. So we have HPA and VPA, like horizontal pod autoscaler and vertical pod autoscaler. So if we talk about vertical pod autoscaler, it means every time we need to go to the deployment manifest file, and the pod specifications we need to increase. It means let's say it's using 1 vCPU, we need to increase for let's say 5 vCPU. So where it will be a downtime associated. Maybe we will do rollout restart, but there might be downtime. So for that reason, the many organizations where they need high availability, that time we are not using VPA. So we are focusing on the HPA. So HPA means it is a horizontal scaling. So I can take example, let's say one person is doing the work, and that work cannot be done in a 1 hour. So to complete those work, we deployed 10 number of people. So that is called horizontal scaling. Whereas vertical scaling means, let's say one person is doing the task, is maybe 2 years of experience, is unable to do that. So we deployed a 10 year of experience back. So that is called vertical scaling, means adding the power, whereas horizontal scaling means adding number of people or number of nodes. So on that cases, if you see this deployment like HPA, so HPA needs, which stands horizontal pod autoscaler. To work HPA, we need metric server. It means metric server will be installed, and based on the pod CPU utilizations, so what we specify, let's say 70% we made the utilizations. So when the pod utilization will be more than 70%, then it will bring the new pod. It means we need to specify minimum replica and maximum replica. It means minimum will be 5 will be running, and when that pod utilizations will be more than 70%, it will bring the new pod. So it can be deleted accordingly. It will be less than 70%, then it will be delete the pod. So at any point of time, 5 pod to be up and running. So that is the behavior of HPA. Now, so the pod will be running in the node. It means the node has some capacity. Let's say some instance type. Node is nothing but your EC2 instance type. So it has some specifications. Let's say 4 vCPU or 8 GB of RAM, 8 vCPU or 16 GB of RAM. That is the specifications of that node. It means maximum that many pod can be created inside the node. If more than pod, let's say HPA will specify minimum 5 and maximum 10. 5 will be running. If let's say load will be more and new pod comes into picture. If node has not capacity that much, the pod will come into pending state because it's a insufficient CPU. If you see here you mention 5. So when you run the deployment, 4 will be running, but 1 pod will into pending state. So if you describe the logs, it will say like insufficient of CPU because the node doesn't have capacity. That case, pod level scaling will not work. It means the node level scaling we want. So that cluster autoscaler comes to picture, which is comes with the default EKS cluster, like the node level scaling. So when cluster autoscaler, what it will do, when the pod will be in pending state, the scheduler check, okay, there is no availability of node, it will bring a new node. Okay, once it bring a new node, the pod can be like assigned to that new node. But what disadvantages of cluster autoscaler is, it works on the autoscaling group concept. It means whatever the instance type we have specified, it will bring at any point of that. It means, let's say here I'm talking about M5 large, which is 2 vCPU and 8 GB of RAM. So 3 node is running. Let's say I need only 1 pod. That time it will bring a new node, like 1 pod will be in a pending state. So but during that time, new node will come into picture, which is 2 vCPU. It means wastage of resources. So to overcome that, the Karpenter comes to picture. It means during your exact requirement, the exact amount of instance type it will choose. So
yeah. So actually at the moment, right, we are in the era of microservices, and many companies have started to adopt the microservices and started using the EKS clusters. But at one point of time, they also reach out to us, right, saying that our costs are very high. Our costs are getting very high. My resources are not being utilized properly, but still I am paying much. So in order to solve these respective problems, like whatever Satyajit has talked just now, if at all you see, even though you are going to get only 1 pod with less number of resources, but you are adding almost 2 vCPUs and 8 GB instance, that means which is more number of resources that we are allocating. And obviously the cost will be higher, and we are wasting the respective, obviously when its cost is right, and we are not efficiently using. In order to address all of these, AWS has come up with an open source project called as Karpenter. It is an autoscaler built by AWS and as an alternative to the cluster autoscaler, which is CAS. CAS is also AWS, but due to all of this feedback they have taken and they have built this. So what it does, why is it so much different when it comes to the other autoscalers? It is because when based on your demand, based on the number of pods that are going to get scheduled, or based on the number of resources that are needed, based on that it will pick up the right instance for you. It's not something like, if at all you take an autoscaling group, if you specify some M5X large instance, anytime whenever new instance is coming, it will only bring up M5X large instance. So here we are having the flexibility in order to choose which type of instance family you want, something like M, T, R and so on. And also if at all you want to include the purchase options into it. So what I meant by purchase options is, we can also include reserved instances, we can also include spot instances into this respective configuration. So that means spot instances, by using spot instance you can almost get save 80% of your cost, 70 to 80% of your cost, right? So that's where we also have this we also can utilize this feature in order to reduce your cost. And it's not only to cost, you are also efficiently using your resources as well. So you're having two types of deployments again. One is static capacity and another is dynamic capacity. So static capacity is nothing but where you are telling the EKS cluster to pick up some certain number of nodes for us. But by using dynamic capacity, what is happening is you're just telling the Karpenter to just make a decision on its own. It's not that you are going to tell Karpenter to bring up what instance of your what instance. Depending on the number of resources that is needed at that particular time, based on that, Karpenter makes a decision, picks up an instance, and then deploys it. And also, it is not well, like cluster autoscaler, it uses the autoscaling group. So, which normally takes time. So, but with respect to Karpenter, it makes an API call, and your instance will be up and running in no time. Also, it scales down as well in that speed. So you are actually making the efficiency, you are increasing your efficiency with respect to scaling, as well as you are also controlling your cost here. So how does Karpenter work, right? So as just Satyajit mentioned about what is horizontal pod autoscaler and vertical autoscaler. So whenever there is a trigger for horizontal pod autoscaler or a new pod to come up, so if the node is having enough capacity, it can accommodate those pods. If the node is not having enough capacity, the pods will go into pending state, and that is where usually, if suppose we use cluster autoscaler will use the autoscaling group and then create the EC2 instance. And since this is an autoscaling group, usually it takes some time in order to trigger the event and then scale it. So what Karpenter does is, when with respect to Karpenter, immediately when it identifies that there is a pending, there are some certain number of pods that are pending, immediately Karpenter brings up an EC2 instance, and it will be up in no time. And it also makes a decision whether to go with C family or R family, M family or T family based on whatever you have configured. And in that family, it will pick up either large instance or X large instance or 2X large instance. It makes a dynamic call and it will bring up the respective instance. So I'm talking about cost optimization. So bring an instance, right? Even the cluster autoscaler does, it will bring up the instance. So but where the Karpenter is making an impact with respect to cost is, if suppose you take a hypothetical situation where you're having 4 nodes, out of the 4 nodes, in one node you're having 4 pods, and in second node you're having 2 pods, and 3 and 4 you're having only one pod each. So that means in the second node, even though you're having the capacity in order to provision 2 pods, you have chosen third and fourth. Instead of that, can I consolidate all of the respective pods into one? So that is where, right, we have the option or the feature called as consolidation. So this Karpenter makes a decision. Okay, it's not only adding a new node, it also consolidates the respective nodes. If it identifies that there are some X number of pods which are deployed in an X node, at the same time it is not being used completely, why can't I take it out from that and put it into a new instance? So that's where the cluster optimization comes into picture, and how this Karpenter makes a decision with respect to optimization is called as consolidation. So how does this consolidation happen? So I'm talking about the theory so much, right? How do we implement all of this? So that is where we are having a file called as nodepool.yaml file. When you install an respective Karpenter, you need to configure here. If at all you see here, right, I'm telling in what type of instance should be there. If at all you see here, C, M, yeah, I put it as C family, M family, R family, and instances also I have selected. So instances also I have selected, and at the bottom, if at all you see, I'm having capacity type, where I have chosen spot and on demand. So I mean, I'm not sure if it is visible completely, but this is where, right, we actually specify it. So usually we also can bring in Graviton. So Graviton instances are again 40% cheaper when compared to the normal instances, either Intel or AMD. So you can bring in the Karpenter and you can also use it here. So and how so consolidation, where it should happen, after how much time it should happen. So that is where, if at all you see at the bottom, you are having the respective field called as consolidation after. So it will consolidate if it identifies that there is some consolidation required. It will based on the time we have configured here, it will immediately pick it up and then consolidate it. So this is where, right, we actually define the respective Karpenter parameters. So with this, right, we are talking so much Karpenter and so on. So let's now get into action.
So by that time the demo will be ready. So we have created the prerequisite will be the cluster should be up and running. So we have taken the latest version of cluster 1.30. Though 1.31 just recently checked, but we use the 1.30 cluster. Cluster should be up and running, and the Karpenter is open source, so we install using the Helm. Okay, and create the cluster. You guys know, like, it will take minimum 15 to 20 minutes of time to be ready because the node group and all such configurations using add-ons. Then Karpenter installations also, it will take 15 to 20 minutes of time. So by the interest of time, we created the demo, and we'll showcase what is the cluster and how we install the Karpenter. So how you get to know that Karpenter is up and running, and then we create a deployment file. So we created a deployment file. So where we just increase the replica, instead of 5 we make it as 20, so that the pod will come into pending state because due to unavailability of nodes. And then how the Karpenter will get to know that, and it will bring a new node. Okay, so that we just get to know, and the pod will get into running state. And also once we deleted the replica, the pod will again came back to a so node will gets down. That will just verify.
Yeah. So regarding you mentioned that regarding the auto scaling, so auto scaling when the requirement comes, right? When we have some higher spike in the request, so it comes auto scaling, right? And you say that it's auto scaling gets become in the no time, right?
Yep.
So how that actually happen? Like it preserves some instance in the backend, and whenever the requirement comes, it gets started or something. So it's affect the costing or like how that internally works.
See, the pod level scaling, it is okay because it depends upon the node. Because when you create the EKS cluster, we have to make minimum nodes, right? Let's say 2 nodes we used it, right? It means that 2 node will be up and running at any point of time. So the pod will be running like that. Let's say one node has capacity maximum 4 pod can run, and another node also capacity 4, so maximum 8 pod can run. It means at any point of time 8 pod can run. Okay, so when node level scaling will come into picture, when we, let's say there are number of loads more, like let's say number of requests are more, that time what will happen, we given the HPA file, the pod should be, let's say 16. Okay, when it means it will backend 16 pod will be created, right? But that pod will be pending state because the node is not available. That time Karpenter will understand, okay, scheduler is saying, okay, bring a new node. So that time the backend configurations mention M series, a C series, a T series, right? So let's say M series means your memory optimized, C for compute optimized, and T is a general purpose, right? So based on that, it will bring a node, and the pod will get assigned. And when the number of loads are more, number of requests are less, it means pod will, HPA will again delete those, and HPA, whatever the minimum we specify, let's say 5, again it bring back to 5. So the new extra node which you created, it will get again deleted.
So we keep that pod in the pending status, right? So that it affects the our costing, na?
No, the pod will not. So it's a matter of, that's the reason cluster autoscaler, it will take a matter of 1 minute of time. So that pod will between pending state to running state. But whereas Karpenter, it is in milliseconds. It means immediately, it will, like when the pod will come, it will be pending. Then immediately node will be created, pod will be assigned to that node. We'll just see the demo so that you will be.
Okay. Okay. Yeah. Thanks.
Suppose we have one replica for one application, okay, and that is scheduled on Karpenter managed node. So when Karpenter is performing the consolidation, at that time that node is terminated. So our single replica of pod is terminated, and we will get downtime. So like how we can handle.
So it will be working as a deployment, right? Rollout. It means, so let's say 5 pod is running, let's say, okay, there are 2, Karpenter brings new node, let's say 3 nodes. and one node has capacity, each node has capacity 444, okay. Let's say 2 pod is running in one node, another 1 pod is running in another node also in one pod. So when consolidations, when you mention 30 seconds of time, so every 30 seconds Karpenter will check what is the capacity of the node and how many resources, how many pods are available, right? So based on that it will check, okay, there is enough node is there, but why this unused node, underutilized node is there. So Karpenter, what it will do, so let's say when you ask about one replica, right? When it is one replica, so that time it will not do anything. But it's a matter of, let's say, because one replica when it migrates, there will be downtime associated. But if it is two replica, it will say one by one. One will be going to that other node, one will keep, and then once that is available, then it will bring to the another node.
So you mean like if we have one pod on a node, so that node won't be considered in consolidation?
Because see, when I said Karpenter will come,
Satya, just demo is going to this. We'll take your questions.
Yeah. If you see the cluster we have created, the name is Satyajit EKS cluster, and which is of 1.30 version. Okay. And in the compute we have one node group which is desire size 2. It means there will be 2 EC2 instance will be running on the backend. Okay, which is M5.large type. And M5.large type has 2 VCP and 8 GB of RAM. So maximum 2 pod can run if you specify 1 CPU per limit. Okay. Now Karpenter we have already installed. Karpenter will be created in the Karpenter namespace. So that's the reason if you see 2 nodes are there, and we can check the Karpenter will be running in Karpenter namespace. So this is the deployment file. So there is a Karpenter namespace will be created when you install the Karpenter. And when we create the Karpenter, so how you verify that Karpenter is up and running? If this both the pod will be in a running state. If that pod is in pending state, not running, then you know Karpenter is not installed properly. Now we have created the deployment file. Deployment file has 0 replica. We will increase into 10 or something, right? So we have specified CPU equal to 1. So it means only one CPU can take whenever the pod. So we added 5. Yeah, we added 5. So our 2 nodes is running. So maximum 4 pod can run. So 1 pod will come into pending state. Once we apply the deployment file, we already verified 2 node is running, right? So if you check the pod now, because it's a node, right? The default other the EBS, CSI driver, other they're consuming some CPU. But if you see the pod is in pending state, we check the status of the pod. It will say like insufficient CPU. 2 nodes are running and 2 insufficient CPU. So that time, as already Karpenter is installed, we'll see the node count now. Okay. If you see the node count, if you're not ready state in 5 seconds ago, it means new node comes into picture in the backend. Okay. And we see the Karpenter logs now. If you see the logs, node will be created. The message created the node claim means it's calling to the node pool and created the node claim, and it requests okay how many pod it wants. Based on that, it created the instance type. And if you see the pod status now, all the pod will be in a running state. Now node will be ready, okay, because new node it came, node is ready, and we see the pod status now. All the pod will be running state. It was earlier pending state. So now what we will do, we will delete the pod. Replica will make it a 0 again. Okay. So new instances came with C6A 2x large because we have specified C series, right, in the node pool configurations file. Now what we will do, will again deployment will bring back to 0. So what will happen? The new node will be automatically deleted. Okay. So we see. So again made it a 0. We apply the deployment file. Now all the pod in 0. There will be no pod running. Now we check the node status. Keeps it will get nodes. Okay, we check the logs now. The logs, it will be calling us tented and it will show us deleted. So every time logs will come, so we just started. If you see now, tented node. Okay, so it is tenting, then after that is a deleted node. So the new node which is created, it is deleting. And if you check the kubectl get nodes, the node, there will be only two nodes. Back earlier was there two nodes, it will be coming to two nodes. The new node which is created, it got deleted. Please submit. So we'll be around here, so if you have any questions, we can discuss. Thank you everyone.
Thank you everyone.
Thank you, Nagababu and Satyajit. You have given us all the scaling superpowers we need. Now, if only we could scale our weekend plans like that. Fantastic session.
I would like to call upon Harshal Doshi on stage to present a token of appreciation.